Today we are going to discuss about the assignment number 10 in dealing with materials data collection, analysis, and interpretation. So let's go through one by one. So uh, first, would like to explain about the how we have got the estimator alpha and beta for the linear regression, least for regression. So alpha representing the intercept and beta representing the slope. How we have got because that derivation was left for our own purpose by the math. So on the personal interest, I will take it and I'm going to solve it here. So after that, we directly go with the regular problems. So first is simple linear regression. Um, Formula is like y is beta naught plus beta x1 plus beta 2 x2 plus k1 plus beta and xn. So this can also be alternatively represented as one second. Skip the variable r beta r x r plus the error because without the error we can never get the 100% fit. So we always have this error term, and we have studied the expected value of the error is equal to zero because our aim is to make the error zero. So which means like the expectation of the value of the error, like if this is the expected value or line, the error should fall within that and it should tend to zero. That is what our aim is. Like the ball getting attenuated and coming to the rest, our error value should be close to zero. So that is what our solution is. Our requirement is for this defect. So here beta naught, beta 1 are regression coefficients, and x1, x2, x3 up to xr are the given values. Okay, so sorry. Okay, so in case of simple linear regression, we can reduce this to 1 is equal to beta naught plus beta 1 into x plus epsilon. So we can reduce it to this way, and we can get the sum of the squares, or like we want to estimate the error. So how we will estimate the error? So error can be estimated by y minus beta naught minus beta 1 x1. Like here, only one x is there, so we will get it as x. So um, this. So like if it is for one value, it is for one value of x, it is x. So if it is for multiple values of x, we'll keep it like xi and summation of I varies from 1 to n, because generally we will be giving n number of values, n number of inputs to the for n number of x values to fit the curve. For that, we have to input multiple x so that we are modifying the equation from normal x to xi, and we are giving y equal to 1. Okay, so what our aim here is to um, So this is similar to some of the squares you can see. It's like it's not equal to what is called, but this is called residue. So this is residue. But the thing is, the sign is always a problem because the residual always tends to zero. So we cannot get some of the residuals tends to zero. So you cannot get a meaningful output from this. Hence, we are squaring it. That results in sum of the squares because we are summing up everything and we are squaring. We are summing the squared things. So sum of the squares can be given by I is equal to 1 to n y minus beta naught minus beta 1 xi whole square. Okay. So now our aim is to reduce the sum of the squares. So minimizing is the criterion. So we do it with respect to first beta naught. So that will result in minus 2 into exponential of is equal to 1 to n then yi minus a minus b into x. And for minimizing, we equate it to 0. Similarly, um, just with respect to beta 1 is equal to minus 2 into is equal to 1 to n xi into yi minus a minus. Okay, here I mean this is beta naught, the beta naught minus beta 1 xi equating it to 0. Okay. So upon substituting upon equating it to 0, what we get is b is equal to, beta 1 is equal to covariance of, okay, let's keep it like this. Xi minus xi bar, xi minus x bar into I divided by I varies from 1 to n, so I varies from 1 to n, xi x bar x bar, okay. Or export. So what we get is this we can call it as y, and this we can call it as sxx. So this is the estimate of beta. So alpha we can easily beta alpha or beta naught whatever you want to do. So beta naught can be easily estimated by because y is equal to beta naught plus beta 1 beta 1 into x, right? So now to estimate beta naught like y this is mean y bar minus beta into x bar. So if we estimate the beta 1 first, we can estimate the beta 1 consequently. So, yeah. So now we have got for the formulas of beta 1, that is S y by x x. Um, Actually, this you have doubt like how we are presenting xi minus x bar into y in terms of x1 and ssx. We can do this as a separate exercise. I'll do it much. And I will prove them they both are equivalent. So so y y xi minus x bar into yn in summation of 1 to n is equivalent to psi minus x bar into yi minus y bar. So this one we will solve this down here. Sorry, we'll go from the reverse. So xi minus x bar into y minus y bar can be written as can see here psi minus x bar to yi minus y bar can be expanded and written as xi into yi minus y bar or here like we can write y into xi minus x bar minus sum of here also sum of y bar into xi minus x bar. So again this can be written as sum of y into xi minus x bar minus y bar, we can take it off into xi minus x bar. So we know the sum of the residuals always tends to 0. So you equate it. This will become 0. So hence proof like yi into xi minus x bar is given as the coins I mean s x bar. I think this explanation will be fine. So with this understanding, now we know how to estimate the beta 1. Beta 1 is nothing but sxy divided by sxx, and then from after estimating beta 1, you can estimate beta naught. Okay. Okay, different people call it in different name, like alpha. Instead of beta, people call alpha and beta, A and B. So use accordingly. So first question, the study was conducted to understand the effect of temperature on process yield of a chemical process. The average percentage of process yield is linearly related to the process temperature. The set of observation is given in the table below. Okay, they are given the temperature in degree Celsius and the process yield in percentage. So they are asking us to fit the least square regression line. So and determine the slope and intercept. So they want us to find the alpha, which is the slope, which is the intercept, and beta, which is the slope. And they are given how many data points? One, two, three, four, five, six, 10, around 10 data points they are given. Don't think it is a two different table. It's a single table only. They given 10 data points and they are asking us to fit it. So for that, we know just we take temperature as x. Sorry, temperature as x and process yield as y. And let's find the sxx. So okay, I've solved it here. So generally I find the covariance. Covariance means we have to divide it by n for n minus 1. N is for population and n minus 1 for sample. So since for variance in covariance you divide by n, so it doesn't matter. You can keep it as n itself and you can divide it and you can reduce your calculation time. So what you can do here is first you have to find Sxx because that is what we are trying to find here, right? Yeah. Sx as per the formula, first we have to find the slope. First we have to find slope. So for finding the slope, um, what is required? We have to find Sxx. So Sxx you can find it by finding the x bar. So x bar is 675. I have already calculated to save the time so that we can discuss more theoretical part of it. And y mean also I have just calculated. It is around 55.55. Okay. So I mean also we have found. So x sxy also we have calculated. So that is 1182.5. So from this, um, actually here I have divided by n. So you don't have to divide it by n. You can just use it as it is. And you can find the value. It will result in b is equal to 0.057. It is a beta 1 value which is slope. So from this we can tell either this one or this one should be the right answer. Next you have to find the alpha here in the sense beta naught. In beta naught or alpha whatever. So for that you just have to find y bar minus beta into x bar. So what is y bar? Y bar is 55.55 minus beta is 0.057 into x bar 675. So when you find beta, it results in 16.0. So it will end up in, so sorry, have wrongly marked the answer. So answer is C. So going to the second question. The least square simple linear regression model is defined as y is equal to alpha plus beta x plus epsilon, where alpha, beta are constant, epsilon is a random error term. Which of the following assumption regarding the error term is correct? Okay, the error term has a constant variance. Okay, the value of error term is random and independent. Okay, the expected value of the error term is 0. So as we have discussed earlier, the expected value of the error term should be 0 because that is what our expectation is. Like the error should fall close to the 0 line. So that gives us the best fit. And I hope this should be clear. We can do simple math to prove this. Okay, let's try this. So, according to the simple linear regression model, yi is equal to alpha plus beta x plus epsilon. So, epsilon is equal to y minus, not I here, y minus alpha plus beta x. Okay, so when we find the r square, so r square is the sum of the least squares. It's 1 minus summation of yi minus y bar the whole square divided by expected value divided by summation of y plus y. So the expected value divided by the actual value yi bar the whole square. So this can also be written as r square is equal to 1 minus summation of y is equal to 1 to n. So this is the y cap. The y cap whatever is a predicted value. So that is what we are referring to here. So yi substitute the alpha plus beta x divided by summation of I is equal to 1 to n yi minus y bar the whole square. So yeah, here whole square. Now for the best fit or ideally we should get r square value equal to 1. R square as a coefficient of determination. When it is reaches 1, we call it as best fit. So we equate for that to happen, we want the numerator to become 0. So if the numerator wants to become 0, this inside term should become 0. So inside term, what is inside term? Y minus alpha plus beta x. Y minus alpha plus beta x is the error. So we want error term to become 0 for getting the best fit. So that is how we tell expected value of the expected value of the error is 0. Okay. So I hope this should be clear. Moving on to the third question. Moving, one second. Moving on to the third question. Why is the response? Sorry. So the expected value, the error term is 0. That is the answer for this. So we have proved it also. Y is the response of an input value xi, then the least square estimator is y is equal to a plus bx. The sum of the square of the residuals is equal to, yes, the random error follows normal distribution with variance equal to sigma square. Then what type of distribution is followed by the ratio of sum of the squares of the residuals and sigma square. So ratio of both follows because already we know from previous understanding like the variance follows the chi-square distribution, uh, chi-square distribution, and also here the sum of the squares of the residuals. If you see, um, residuals follow or errors follow the normal distribution, but their squares doesn't need not be following the same normal distribution. Hence, they don't follow this normal distribution, and same is applicable for T distribution as well. Because T distribution is a subset of normal distribution, and then F distribution is just an estimator of the fitness, how well is the fit, the fit like linear fit or whatever be, how well it has. So that is F is used for distribution used for estimating. So F distribution is also not correct answer here. So since sigma square also follows chi-square distribution, ratio also follows the chi-square distribution with n minus 2 degrees of freedom. So if you ask why n minus 2 degrees of freedom means already in our parameter we will estimate the estimate A and B. So we already know A and B. That's why like, we are making n minus 2 degrees of freedom. So I think this should be very clear. So moving on to the fourth question. If the hypothesis beta naught is equal to is considered a simple linear regression model defined as, okay, beta is equal to 0, which of the following conclusion is correct? Okay, let's just see what is turning out if we give beta is equal to 0. Shit, 1 second. Sorry. Yeah. So if beta is equal to 0, y is equal to alpha plus epsilon. So we know this is a constant. This doesn't vary with respect to y. This is also intercept. This also won't vary with respect to y because there is no x term here. So which means like this is alpha plus epsilon. So it remains. It doesn't. It doesn't depend on any x value. So there is no relationship between x and y. That is a simple answer to this question. Okay, moving on to the fifth question. If A and B are unbiased estimator of coefficients alpha and beta of a linear model, yi is equal to alpha plus beta xi plus epsilon I, then estimator B of beta follows. So as we know, B is given by Sxy divided by Sxx. So they follow the normal distribution because in this case uh, beta beta is an estimator which has a uh, which has the estimated value of value which is equal to beta. B is the estimator which has the estimated value which is estimated to which is the estimated value of beta. Hence, this is the mean value, and the distribution is given by sigma squared by Sxx. So, but the distribution, this distribution of the standard deviation follows the chi-square distribution. But the beta, sorry, the estimator B itself follows normal distribution. So answer is C. Moving on to the sixth question. Okay, sorry, I clicked the answer itself. Study is conducted to estimate the removal efficiency. Once again. A study is conducted to estimate the removal efficiency of air pollution particles from air after the rainfall. The percentage decrease in pollutant particle concentration before and after rainfall is measured during the different times of the year. The data are as follows. So with respect to rainfall, they are seeing the decrease, they have estimated the decrease in pollutant particles in terms of percentage. Excuse me. So moving on to solve this problem. First, find the least square estimate of the regression coefficient beta. So they are asking us to find the beta. So for that, we know beta is equal to S x y by S x x. So for that, um, x bar is equal to 60, y bar is equal to 22.47. So Sxy is given by 132.52. So you can find these things. Means I can also write here elaborately, but it is only waste of time. I'm not going to do this here. Rather, you can do it by your own. So divided by Sxx is given by unsecure. This can also be written as xi minus x bar into yi minus y bar. This can also be written as xi minus x bar the whole square. This is x-axis is 700. So when we divide this, this gives to 0.189. Yeah, so this is the answer. So as a continuation of this question, you can see using the given data in the question 6, calculate the 95% confidence interval for beta in regression line. So earlier we have estimated the beta, uh, and here you can directly estimate alpha also. It's very simple. Just you have to plug in y bar is equal to alpha plus beta x bar. So alpha is equal to y bar minus beta x bar. So you have all the answer here. You can substitute and get the alpha, but that's not the continuation of this question. They're asking using the given data in the question 6, calculate the 95% confidence interval for beta in the regression line. So for a confidence interval of 101 minus 8% confidence interval, the estimate of beta is given by d minus square root of sum of the squares of the residual divided by n minus 2 into sxx into t of a by 2 comma n minus 2. And it's like basically b plus r minus this value. So for this, we have to estimate sxx and syy. Sorry, here is xx and some of the squares of the residuals also we have to estimate using this formula. So after that, we have to substitute and find the t value from t table. Yeah, yeah. Already we know the sxx value. What is that? 700. SSR is given by 700 into what is SYY 132.52 minus SXY covariance. Oh, sorry, that is 132.52. So SYY we didn't estimate it. Okay. Or we have estimated it. How is it? Okay, we can estimate SYY. 1.5 minus. Please, you also try along with me. I'm doing the calculation. So, what is y value as 25.79. So, 19.05. So calculating this, and we have got already what is B? B is 0.819. So we will get the okay, but from for the T score, we will get it from 0.025 significant value. What we get is 0.025 and degree of freedom n minus 2. So totally 7 variables are there. So n minus 2 is 5. So the value is 3.163 is the value. So with this, when we substitute the value, totally we get 0.189 plus or minus 0.025. So it ranges from 0.214 to 0.164. Actually, it is not there in the option. I think there should be some mistake from my side or their side. I'll clarify that. Like, come for the next session. But this is the way we have to solve the problem. Okay. Moving on to the ninth question. So the closeness of the coefficient of determination R square to 1 in place. Observations are more closely grouped about the least square estimated regression line. So it is like it is fitting the our predicted line. So that is what the meaning is. This is closely falling into that group. That's what. So, okay, I think we have jumbled the eighth and ninth question. So eighth question is like if coefficient of determination R means the coefficient of determination is R square, it's equal to 1, but then correlation coefficient. So determination is R square, correlation is R. So when you take square root of 1, it is plus or minus 1. So it can be either minus or plus. So good thing with the correlation coefficient is it will tell like how the variables are related positively or negatively. linearly or non-linearly. But the magnitude is given by the coefficient of determination, like how well is the fit. So because here the R value between 0.5 to, for example, 0.5 to 0.7, how much is the improvement in our fit? In terms of it, how much is improvement? Cannot tell with respect to R. We can tell like 20%, right? But that's not true. So when you take R square, it is 0.25. R square of 0.7 is 0.49. So this is like two times better fit. So from 0.5 to 0.7, we are getting two times better fit. So that can only be explained by the coefficient of determination. So just wanted to introduce this. So yeah, so the answer is clear. Can be either -1 or +1. So moving on to the 10th question. If there is a quantity X measured by conducting three different experiments in five different labs, then degree of freedom of the sum of the squares of X within the laboratory and between the laboratory are respectively. So degree of freedom between labs is given by the DFD, given the number of labs, because between labs mean number of labs which we are taking into account into n measure minus 1. So here we know we're taking five different laboratories and conducting three different experiments. So 3 minus 1, 5. So degree of freedom between labs is 10. So degree of freedom within lab means how many measurements we are taking? 3. So number of measure minus 1 just gives the degree of freedom between within labs. That is 3 minus 1, 2. That's all. So sorry for the what to say, noise and everything. This means I'm not feeling well. So if you have any doubts, you please feel uh, feel free to write to this mail ID. Yeah, I'm ready to assist in person. So thank you. Cuma kemarin dong kan?